Multiplying and dividing with exponents level 2. Start with the original problem. 5 to the negative 1 divide by 5 to the negative 2. All of that is multiplied by 5 to the negative 3. The key with today's lesson is to simplify the fraction. So I'm going to simplify 5 to the negative 1, divide by 5 to the negative 2. Please remember that when the base is the same and we're dividing, we're actually going to subtract the exponents. So I'm going to put 5 to the negative 1, subtract a negative 2 like that. And then we're going to rewrite and put 5 to the negative 3. I'm actually going to simplify this negative 1, subtract a negative 2, and I'm going to rewrite 5 to the negative 1 plus 2 multiplied by 5 to the power of negative 3. Negative 1 plus 2 is going to give me 5 to the power of 1 multiplied by 5 to the power of negative 3. And now that I'm multiplying, when I have the same base, I will actually add the exponents together. So then I would write 5 to the power of 1 add a negative 3. And then that'll simplify. 1 add a negative 3 is going to simplify to 5 to the power of negative 2. I'm going to box this. This could be my option as my answer, and it is. But I do want to remind you that you could get rid of the negative exponent by moving the base to the reciprocal position and then changing the negative 2 to a positive 2 exponent. So another option would be 1 over 5 squared. And then because the exponent's pretty small, you also could go ahead and rewrite 5 squared as 5 times 5, so it'd be 1 over 25. Again, all the boxed answers are equivalent. But typically, they're not going to have you multiply it out if this exponent is larger than probably a 3 or a 4. I'd suggest before you get started on this one, pause and try this on your own. So 5 to the negative 3 multiplied by 5 to the power of 7 divide by 5 to the power of negative 7. Again, I'm going to work by simplifying the fraction to start. So my first one I'm going to rewrite as 5 to the negative 3. Now I'm going to take 5 to the power of 7 and I'm going to divide it by 5 to the power of negative 7. And when I'm dealing with division, same base, we subtract the exponents. So 5 to the power of 7, subtract a negative 7. We'll simplify this negative as 5 to the power of negative 3 times 5 to the power of 7 plus 7. Again, negative, that's going to switch to a positive. So now I have 5 to the power of negative 3 times 5 to the power of 14. And now finally that the fraction's simplified, we can go ahead and just multiply. 5 to the power of negative 3 times 5 to the power of 14. When I have the same base and I'm multiplying, I add the exponents. So I write 5 to the negative 3 plus 14. And then finally, 5 to the power of negative 3 plus 14 is 5 to the power of 11. And that's going to be 5 to the power of 11. Cut that right there. Do you remember we could write this as a reciprocal? I can move the base 5 to the bottom, and then that positive 11 could change to a negative 11 and then put it over 1. But they probably wouldn't have you multiply 5 by itself 11 times. Third example. So now we're dealing with a complex fraction. So step number 1 is, again, always rewrite the original problem. 4 to the negative 3 times 4 to the power of negative 2. That's all divided by 4 to the power of negative 3. When we're dealing with these complex fractions, the first step is we want to simplify everything in the numerator and everything in the denominator. Now, I will let you know in the denominator, it's simply 4 to the negative 3, so we'll just rewrite this. But in the numerator, 4 to the negative 3 times 4 to the negative 2, when I have the same base, I'll add their exponents. So I'll put 4 to the negative 3, add a negative 2. So in the numerator, I have 4 to the negative 5, divide by the denominator, which is 4 to the negative 3. Now that I have the same base, I have base 4 and base 4, when we're dealing with division, we subtract the exponents. So I'll rewrite it as 4 to the negative 5, subtract a negative 3. Of course, by now you realize that we have a double negative, so we should take a moment to rewrite that as 4 to the power of negative 5 plus 3. And then 4 to the power of negative 5 plus 3 is going to be 4 to the negative 2, which that could be a viable solution. And it looks like it is here. But please remember that we could get rid of the negative exponent by moving that base 4 to the bottom, the reciprocal, and then the negative 2 exponent becomes a positive 2 exponent. And then don't forget to put a 1 on that. And then lastly, you could go ahead and simplify 1 over 4 squared as 1 over 4 times 4, which gives you 16. And again, sometimes Delta Math will have you evaluate to find out what 4 squared actually simplifies to. But typically the power here has to be usually a 1, 2, or a 3. Anything 4 or more, the numbers get a little bit, they get really large really fast. Before you finish off the last one, I'd suggest you pause the video and give it a go on your own. So 2 to the power of negative 6, that's already simplified in the numerator, so we're going to have to simplify the denominator, but we'll write it out first. 2 to the power of negative 8 times 2 to the power of negative 7. So my first step is I'll simplify the denominator, and 2 to the power of negative 8 multiplied by 2 to the power of negative 7, when my bases are the same, I add the exponents. So it's going to be negative 8 add a negative 7. Rewrite the numerator of 2 to the negative 6. Okay, now a negative 8 add a negative 7 is giving me 2 to the power of negative 15. In the numerator, it's 2 to the power of negative 6, so we're still doing fine. And then we have our division. 2 to the power of negative 6 divided by 2 to the power of negative 15. When we have the same base, we'll subtract the exponents. So I'm going to write 2 to the power of negative 6, subtract, and the number on the bottom is a negative 15. If you notice that we have a double negative, that's great. Again, take a moment to rewrite that. Again, we don't want to skip steps. So I'm going to put 2 to the negative 6 plus 15. And then negative 6 plus 15 is going to give us 9. So I've got 2 to the power of 9. 9's a pretty big exponent, so they're probably not going to have us multiply that out. But I do want to remind you that we could go ahead and write this as a negative exponent by moving base 2 to the reciprocal position, which is the denominator, and then changing that positive 9 to a negative 9. So 1 over 2 to the negative 9 would also be equivalent. But in this case, they have 2 to the power of 9, so we are good to go. And that's it. Thanks for viewing. And again, please show more work rather than less. Do not skip steps. And have yourself a great day.